What we're going to talk about is just some portion of this concept called functional programming. Have any of you guys heard about that? Does that ring a bell for anyone?
Yeah.
Yes? Over here? Okay.
Object-oriented.
What's that?
Versus object-oriented programming.
Yeah, so object-oriented programming is another paradigm. Functional programming is a particular paradigm that's centered around functions. Okay? And in JavaScript, there's something about functions that makes them kind of special. They can be passed around just like any other thing. They can be passed around like strings can be, like objects and so forth. So what that allows us to do are some pretty powerful things. And we're going to see some examples of that with some functions called forEach, map, and filter. These are things that you'll see, well, generally map and filter will be used more in a React sense, but I'll show you guys forEach as well so you have a reference to that. All right, so what we're going to do, I'm going to create, or I've already created this JavaScript file, and I'm going to have it running constantly in the background. So we've got this tool called NodeMon, which will refresh our terminal every single time we make a change to it. All right. So if I come down here to my terminal, I'm going to run this file using NodeMon. Functional programming.js. Why is it trying to run my React thing? Oh, I'm in the wrong folder here. Hang on one second. Let me get out of there. Okay, let's try that again. Whoops. Okay, so it's waiting for file changes. There's no code in there, so obviously we wouldn't expect anything in our terminal, right? Let's create an array. So I'll just say numbers equals some array of numbers, 1, 2, 3, 4, 5. And what we want to do is we want to run a function on every single one of these numbers. Okay? So maybe our function will be something along the lines of, let's just print out my number is whatever. Right? Does that sound good for you guys?
Sure.
Okay.
All right. So how would we go about doing this normally? Like if you guys were presented this as an algo, how would you handle that?
If you created the function that would take the argument of whichever index of number, first number, the fifth number, the fourth number, the third.
Okay, so let's just start with what you said. So let's create a function, right? So function say all the numbers, we'll say, right? And then that will take in some array. All right? So inside this function body, whoops, what would we want to do? What would your gut instinct tell you to do? What's that? A for loop. Very good. So that's going to look something like this, right? For let I equals 0, I less than r dot length, right? And then we would, whoops, increment I. And then what I might do is I might say something like console.log the number is, and then I could just concatenate array at I, right? All right. So the thing about this is that we actually had to worry about a lot of parts of the iteration process, right? We actually had to create this temporary variable I. We had to say when we wanted this iteration to stop, and we also had to increment our I. All of this stuff that just seems like boilerplate code, right? I mean, it seems like there's got to be a better way to iterate through these things without creating temporary variables like that, right? Turns out there is. Okay, so every array that you guys have access to is going to have this method on it called forEach, which means that I can call some function on every single item that's in my array. So let's see what that looks like. So we can say numbers, and I'll just comment this out. Actually, let's invoke this and make sure that it actually does what we think it does, right? So we'll say all the numbers, and then I'll just pass in that numbers array that I've got. save the file, and of course we're getting the output that we expect. So that's cool. All right. But now we want to do this in kind of a cleaner, more functional way. Okay? So let's try it out. Let me comment these guys here. And instead of building up our own for loop, we're actually going to say numbers, dot forEach. Okay? Does anybody know what forEach takes in? No, the elements are coming from here, right? We already have them. No, it's not going to take in an array. Number? Takes in a callback function. It doesn't actually take in any numbers. We need to pass in some function that we want to run on each number in our array. Okay? All right. So let's create a function that we want to run. So if I wanted to create this as, say, an arrow function, I can do that up here. I can say const say number, and then I can set that equal to a function, right? So if it's an arrow function, it might look something like this. Number, that's the argument that we're expecting. And then I'm just going to grab this up here because this is what the console log is going to do, and then I'll swap that out. Okay, so instead of array at I, what am I going to put inside here? Number. Okay. There we go. All right, so what this function is saying, or what's happening here, is we're creating this constant variable, say number, and then we're assigning that to this function right here. The function is going to take in some number, and then it's going to console log the number is, and then the actual number as well. Okay. So now if we want to run this forEach function, I can simply pass in this function inside there to invoke it. Okay, so let's try that. I'll just drop in say number. Okay, and the result is exactly the same. Same thing, right? Can you guys kind of see what the benefits of this approach are? How we kept things very clean. We didn't really worry about how we were doing the iteration. Who's doing the iteration for us? This forEach is actually the thing that's iterating through our items. And then it's just invoking that callback function against each one of the items in turn as it goes. Pretty nice, right?
Can you, question.
Mm-hmm.
Can you put the callback function, without declaring the constant say number function, put it in the forEach?
Yes.
As an anonymous?
Yeah, we can definitely do that as an anonymous function. So part of the reason why I didn't do that initially was just so that we had a very clear distinction. You know, like here's our function, here's what we're passing in here. But absolutely, as Juan said, we can basically define that function right in line. So instead of having this, let's just take this, and I'll replace that here. Okay? And now I can comment that out, and again, same exact input. Okay? So sometimes this is a little bit unclear for people to understand, which is that, you know, we've now declared this function in line inside when we're invoking another function. So it becomes a little bit harder to read sometimes, right? Have any of you guys ever heard of this term callback hell before? So it's the situation in which you have nested callbacks, which start to create this pyramid of doom type thing. So your indentation continues to move to the right of the screen, and it becomes very difficult to read. Okay, so that could happen if we were nesting callbacks. Now in this case, it's only like one level deep, right? I'm just putting one callback in here. That's it. Anything deeper than that, though, could become unwieldy.
Do you have
yes.
like an example for callback hell?
There was actually one in the platform. Remember we were looking at that deck of cards thing? And it was I mean, it wasn't bad. It wasn't like Callback Hell necessarily, but as we were creating the deck, we did a forEach through one thing, and then we did a forEach through another thing, right? It was kind of like this nested situation happening. You could see the indentation was starting to move to the right. So that wasn't like a horrible example, but there are a lot worse examples out in the wild. All right. Does everyone feel pretty good about what we did here with forEach? Okay. One thing I wanted to point out too is that there's another argument that you can add on here. If I wanted to have access to the actual index of that item that I was looking at, I can add that to my callback as well. So let me just uncomment this. We'll put say number. So if I wanted this to take in also the index, I can go like this, number index. One thing you guys should note is that I added these parentheses here. If you have more than one argument, you're going to have to add parentheses like that. If it's just one, you can have it without the parentheses. Yes?
Is there a limit to argument or
To the number of arguments?
yeah?
Not that I know of, but you generally don't want to have too many
Okay.
because then it makes things very difficult to reason about.
Question: if you don't have a second argument, do you still have a parentheses?
Yes. Yeah, you can write them that way every time if you want. If it makes more sense to you to just have parentheses all the time, that's fine.
Like a function.
Right. Totally fine. Yeah, so here, if we now have reference to this index, I can also use that in my callback function as well. So I can say the number is this, and then I'm just going to add on here the index is, and then I can concatenate that onto there, the index, right? Pretty nice, right? We didn't even have to do any looping type logic.
Yeah.
It's just giving us the index each time around. Pretty cool. All right.
How can you go like 5, starting 5 to 0 in forEach?
If you,
Original reverse.
yeah, you could revert. I mean, all right. I'll show you real quick. Uh huh. Oh, they're in the corner office on the desk. Yes. All right. So what we could do is we could take a shallow copy of our array. We could reverse that thing, and then we could run forEach that way. You can't forEach in reverse without like manipulating the actual array first. Yeah. But if you wanted to see that, we could do it like this. Let me just comment this out. So we could do numbers dot slice dot reverse and then dot forEach say number. Okay. So here was what's happening is we're iterating in reverse, but of course we've also changed the indices because now we reversed the whole array.
Right.
So and if you're wondering what slice does, is it essentially takes a shallow copy of the array and gives you back this shallow copy. So that way, if you were to make any changes to the new copy that you created, it wouldn't affect your old array in any way, shape, or form. Okay. So it's kind of useful in that sense. Yes?
On the line, I want to say line 11, is that an apostrophe after number? On the bottom, right, underneath the person? Is that an apostrophe right before the semicolon?
It's a single quote.
Okay, I couldn't see it.
Yeah, sorry about that. All right. So let me just comment that guy there. Okay, good. Any questions about this before we move on to the next one? Can I have thumbs on forEach real quick?
Question index is like a special keyword.
No, you can call that whatever you want. It's just the second argument is going to be the index.
Okay.
You down all the way? You just got here? You missed the best part. Holly? How do you feel about that? Haven't got there. Wait, you were here the whole time, no?
No, but I mean,
Oh, you did?
This isn't React. This is just functional JavaScript. Yeah. Boy, man.
What do you mean? You can say
I thought it was.
anything, doesn't have to say index, so I wouldn't know you're talking about indexing.
Yeah, let's change it. So let's just go sum var. Still works. I can call it whatever I want.
So always the second parameter
The,
is
yeah, the second argument that's passed in will be the index of that item.
If it's an array.
Well, it will be an array. That's we have to use this on arrays, right?
Okay.
And what would be the third element, third parameter?
I want to say it's a reference to the array itself. Let's look it up real quick. So if we go mdn forEach. Let's see. Yeah, so you can see here, these are the optional arguments. The second one is index. The third one is a reference to the array itself. And then optionally, a fourth argument would be if you want to change the value of this inside of your function. You guys probably won't have to worry about that though. But really, these are the only two that I think you'll generally be using. The item and then its index. Okay? All right. All right, so let's keep going. We've got forEach knocked out. Let's talk about map. Okay? So here's the scenario. I've got this list of numbers. What if I wanted to multiply every number in that list by 2? How would we do that, in the way that you guys already know? Anyone want to take a stab at this?
Then we're just multiplying instead of constant volume.
Yeah, exactly, because we want to actually, in this case, we want to return out a new array. We don't really want to change the original one. Okay, so I'll just create a function, multiply all by 2. That's going to take in some array of numbers, right? And then how would we do that?
Or the for loop.
Okay, for loop. But what might I need before I even run that for loop? A new array, right? So say new r equals just some empty array. And then I know at the end of it I'm going to need to return out that new r. Right? Okay, now in the middle here, this function body, this is where I want to have my for loop. So we would do our regular for let I equals 0, I less than r dot length, I plus plus. Okay, and then what am I going to do inside this for loop?
Multiply the value of the I by 2.
Not the value of I.
Oh, the array. The array of I.
Yeah, array at the index of I. And then what am I going to do with that result?
Push it.
I need to push it into this new array right here, right? So we'll say something like new r dot push, and then we'll have array at I times 2. Okay? So now let's test this out. Let's just say const multiplied equals multiply all by 2, and then we'll pass in numbers. And then right after that, let's just console.log multiplied. Okay, and then if I open up my terminal here, so you can see now we got exactly what we expected, right? We got 2, 4, 6, 8, and 10. Good, right? Okay. The code wasn't particularly nice to look at, though, right? I still had to worry about how am I iterating through this entire list. What if I could use a built-in method that would do that part for me? All right, same thing. So let's create a function. I'll just comment this out real quick. We'll create a function that's just going to take in a number and it's going to multiply it by 2. So I'll say const multiply by 2 equals a function that takes in a number, okay? And it's going to return out that number times 2. Okay? Does this arrow make sense to you, what's happening here?
Return number by 2.
Yeah. So where's the return happening? I don't see a return keyword in there. What's causing that?
We use the arrow function.
If we use an arrow function and it's only on a single line, the return will be implicit.
Oh,
It's an implied return. Okay, so that's happening automatically. Okay? All right. Now what I want to do is I want to take that list of numbers that we have and I just want to turn it into this new list that is multiplied by 2. So let's do the same thing. We'll say const multiplied equals numbers dot map. Okay? And what I'm going to pass in is the same thing. Here we need to give it a callback function, right? So in other words, how do I want to transform each input that's in my array? And all I want to do is I just want to take that number and multiply it by 2. That's it. So let's drop that callback in there. By 2. And then let's console log it out. Multiplied.
Supply by 2. No past tense.
Yep. Okay. So it did the exact same thing for us, right? It created us this nice new array that has everything multiplied by 2.
But is this a new array?
It is. It is a new array. Yeah. And that's kind of one of the things about functional programming, if you guys read some articles about it or learn about it a little bit, is this idea that we generally don't want to be mutating something. Rather, we want to create a brand new thing. Okay? And what's nice about that a lot of times is that if we change the state of something from one thing to another, so if I mutate an actual array, it can be hard to reason about my program. Like, how did I get to this new state? What mutated it? Versus if I set up my program in such a way that I really don't overwrite things, I create new variables, then it's a little bit easier to kind of like track the data, how we're getting from place to place, right? That's one of the reasons why functional programming has become so popular and such an important topic in recent years. All right. So somebody's going to read this code for me. I think it's going to be Andrew. Line 30. What's happening here?
Create a constant variable called multiple by 2, and that takes the arrow functions, and that function will take a number.
Hold on. It doesn't take an arrow function. What are we doing?
It will be a function.
Equal sign means we're doing what?
Assign something.
Assigning, right? We're assigning it to
Function
a function.
that will take the numbers,
Good. Take in a number,
take a number, and then multiple by 2.
and then it will return the result of multiplying that number by 2, right? So if I pass in a 10 to this function, I'm expecting to get out a 20, right? Okay, cool. All right, next line, 32V.
That one makes a new variable multiplied, which is assigned to a function.
Hmm?
No, so,
Sure. Watch out, because we've got these parentheses over here. What does that mean?
what is a function that?
It means the function's actually being invoked,
Yeah,
right?
I don't get the mock part.
Which part?
The mock part.
Oh, the map part. Okay, so what map is doing behind the scenes is it's running our callback function against every item in the array, and then it's putting all of those results into a brand new array for us.
This is just. So what's the difference between the forEach and that?
Well, the difference is the forEach just simply runs our callback function against every input. It doesn't actually create a new array out of that. So I can have a forEach function that say multiplies every number by 2, but that won't actually give me back an array with all the numbers multiplied by 2. If I want a new array with all those numbers multiplied, I want to use the map function. It's a way to sort of transform all of our inputs in a specific way. All right, so yeah, what we're saying here is this constant variable that we created called multiplied is going to be assigned to the result of invoking the map function on our numbers, and then the map function is taking in that multiply by 2 function, which means that we're expecting a brand new array of all numbers multiplied by 2. Yes?
So does the map function create the array and names it multiplied? Is that what the constant?
No. The name, I could have called this whatever I wanted.
So what would the new array name be?
It's just an object in memory. It doesn't technically have a name until you assign something to it. For instance, if I left off the const multiplied equaled something, well, this new array gets created and then just gets garbage collected right away because it's not being held on to.
Right. So I'm trying to understand the way we defined it, or we created a constant multiplied. Would the new array then take that name as well, or is still in limbo what the array is named?
I didn't do arrays named multiplied.
Yeah, it's only named that because I called it that.
Yeah.
Right. That's what I was asking. So that's the constant. Whatever we put on constant
On the
whatever,
left side,
the array would be named that.
yes.
Okay.
Mm-hmm.
That was a question.
Yeah.
Cool. Thank you. All right.
Question.
Mhm.
What's the difference between map and array prototype map?
Well, it's essentially the same function, right? Because when we're calling map on numbers right there, it's actually finding it from the prototype. It's the same function.
It's just a short way to write it.
Well,
I guess.
the only reason I think why you saw it as prototype in the platform is because we weren't invoking it off of a regular array. You were probably, I want to say it was being invoked off of something else, right? Yeah, but normally if we have an actual array, we can just call it directly like this. We don't need to go and look for it on the prototype. All right. Everyone feel pretty good about map? Any other questions about map? No? All right, cool. We're going to find that map is going to come very much in handy in React when we're trying to iterate through some list in our JSX. We're going to use the map function to do something for each item. Like if it was an unordered list or something like that, we could create those li tags for each item very easily. All right. Cool. The next thing I want to touch on is this other method called filter. Okay. So let's say I wanted to create an array of numbers based on this original array that I set up here, only including even numbers. How would you guys typically do that? Yeah, so we're gonna take in some array of numbers, and then we want to return out a new array of numbers that are all even.
If statement that checks if they're even, and if they are, you append the new array.
Good. Yeah. So let's start from the beginning. So how do we set this thing up? We're going to create a function, right? So we'll say get. We'll just call it get evens. We're going to take in some array, and then again we want to create a new array that we're going to return out at the end, right? So I'll say const new r equals just some empty array, and then at the end I'm going to say return new r. Okay. Then in between this, I'm going to write my for loop. Man, this is becoming a lot of fun, right? I less than r dot length, I plus plus. Sweet. Okay. So what's the condition to push it in that new array? Okay. So we'll say if r at I modulus 2 equals 0, then I use the triple. New r dot push, and then we'll say r at I, right? Okay. Cool. So let's test this out. Let's just come down here. We'll go const evens equals get evens against numbers. Okay, and then let's just console log out the evens. All right, so we got exactly what we expected, right? We got 2 and 4. But again, not so nice to look at, right? I still had to worry about iterating. I still had to create these temporary variables. Sucky. All right, so let's do it a different way. Let's create a function that would simply take a number and return out whether that number is even or not. Okay? So I will comment out some of this here. Actually, okay, comment that out, and then let's create this function. So we'll say const is even. I'm going to assign that to a function that's going to take in a number. And then I'm going to return number modulus 2 equals 0.
The number is a keyword, should be always number, or we can choose any name for that.
No, this could be called whatever you want. I'm calling it number because it actually is in this case, but we could also change it to num too if that makes it a little less confusing. Num. All right. So let's read this function to make sure we know what's going on. Dan, read line 49 and explain what's happening.
We are a function that's gonna.
So over here, what are we creating right off the bat?
An even.
We're creating a constant variable. Okay. All right. Keep going.
Setting a constant variable.
Equal sign means we're doing what? No, it doesn't mean we're invoking anything, right? We're assigning. Very good. Perfect. All right. What are we assigning it to?
Assigning it to.
I've got this arrow in here. Something, the arrow's pointing to something. So what does that generally indicate? This is this new kind of syntax that I've been showing you guys, right? That's an arrow function. All right, cool. So my arrow function does what exactly? What's happening here? Num, so that's our parameter, right? Okay, and then the arrow, since it's only a one-line function, it means that we're going to return whatever comes to the right of the arrow. So what are we returning here? Okay, no worries. Little help? Anyone want to pick it up from that spot?
We return word of all the numbers that when divided by 2 equals 0. Even number.
I'm only actually looking at one number right now. One number.
So
Manny.
it's pulling the numbers from the array that we have, one at a time, and it's dividing by 2. And if the result of that division is 0, it's going to return it because we're looking for even numbers.
You're getting a little bit ahead right now. This function by itself is actually only looking at one number, right? So what are we returning out right here? A Boolean. There you go. Right? we're returning out whether that thing is even or not. So yeah, if we take the modulus of something by 2, and that equals 0, that means that number was even, right? Okay, so that would return true. If it's not, then it should return us false. Okay, so all that's doing is this number even, and that's why I labeled it as such. Right? Okay, cool. So now how can we apply this to actually return a new array with all the even numbers? Well, let's see. What we can do is we can use this, instead of doing get evens like we did before, let's take our numbers and then let's invoke this function called filter. Okay? Just like the other two functions, filter is going to take in a callback function that's going to operate on each individual element in the array. So let's just pass in our function, is even. There we go. And lo and behold, exactly what we expected, right? So again, what was nice about the filter function is that we didn't need to worry about how the iteration worked, right? The actual filter function itself was working through the list, applying our callback function to each element, and then if that callback function, when we invoked it against the element, returned true, it put it into the new array for us. Otherwise, it just didn't do anything with it. It just left it out. Yes?
Could we use map function here instead of filter?
No, because what map is going to do, map will return you a new array that's the exact same length as the original array. We want our array to be shortened, right? We only want it to include the even numbers.
What about the forEach one? forEach function instead of filter?
You could do it. Here's what you would probably do if you were trying to do it with forEach. You would say something like const new array equals that. Only the sucky thing about this is that then we would have to say numbers.forEach, and then I would have to establish some callback inside here, right? Okay, and then if num modulus 2 equals 0, then what would I do? I would say new r.push num. This is frowned upon in the functional programming paradigm because here we are actually modifying some variable that's outside the scope of our callback function. You see? We're now making changes to this thing that's out here.
Why we cannot use the is even function inside the forEach one?
You could. So let's just do that. Let's say if is even. And then we would invoke that against this number, right? Then we would do the same thing. But still what's happening is we're now modifying this thing that's outside the scope of the function.
So the filter do that for us, right?
Yeah, filter does it for us without us really writing very much code at all. We just need to write the callback function that's going to determine, do I want to keep this in my final array? That's all. All right. Question? Yes?
Is there a filter for the opposite condition?
I don't think so. You could certainly negate it though. So for instance, if we wanted odds, we could just create a function that that found odds, right? If you want 0 to be part of that, okay. Yeah. So I would just write another function. Well, is even is already going to do that though. It would already include 0, right? Because 0 divided by 2 is still going to be 0. That'll still be included.
Yeah.
Yeah. Yeah, I'd be fine.
Oh, but I'm trying to think of like if you're trying to, let's say you're going through a
Just make your callback function do that. And then you could just use filter. Right? Because the callback function is where all the power lies. That's where you have the decision to make what's going to end up in my final array. So, bless you. All right, let's have some thumbs on this. Alejandro, you're a little like shaky. Clarifications? Hey, peace signs.
I was like, what is that?
No thumbs, fingers. All right. All right, clarifications, Alejandro. What didn't make sense or doesn't make sense?
Well, it makes sense, but I just gotta try by myself.
Okay. Would you guys like me to post this code so you can play around with it? All right.
Yes.
All right. Totally. It was interesting, right? I told you. All right. Cool. Thank you guys very much. You got it.
Quick question.
Uh-huh.